You might be wondering what this is. Well, this is Toyota Prius Gen 3 inverter. This is something that spurred me on to do the EV conversion. So, why did I choose this one? Well, one of the first things is actually quite cheap. So this one I purchased for £100. So what I'm planning to do with it, I'm planning to swap the main processor board with a design that is done by Damien Maguire. This should hopefully allow me to run Toyota Prius inverter together with a Toyota Prius Gearbox as an electric motor. So the next step for me would be to get my hands on the open inverter board. So I've decided to do it a hard way. Rather than purchasing a ready-made and tested board, I will upload the designs to the JLC-PCB website and let them make and assemble the board for me. But I will have to do all the testing and solder all the missing components on the board as well. While I'm waiting for the boards, I opened the inverter. It wasn't really easy not to crack, I should say. I had to use sharp carpet knife to get in between the sealant and crack open the top lid. Here we go, the board is out and now we have an empty space waiting for the new brain. Today I received a new boards from JLC-PCB. And I'll be working on turning this into that. Surprise, surprise, I found that my board is bigger. So what could I do? I used the Toyota board as a template and marked the holes on my board. I used one of the blank boards to drill the holes in it first and then use it as a template to drill the holes in the board that was assembled. I see my pilot holes line up very well, so I could now drill the main board. And now main board drilled, I found another problem. The edge of the board is extended a little bit too far, so it was resting on the edge of a mounting bracket of the inverter. I decided to trim a couple of corners. Cutting corners, I thought that was not in my character. First, I will solder a JST connector. I placed flux on the connector's track pads and I use a drag soldering technique to solder through the connector. Okay, so now we connected the 12 volts and we have indication that power is working. We need to check the main supply voltages and I check 3.30. That's great. The next one is a 5 volt, it's 5.00, that's perfect. So we have all our power in place. Now we need to program the STM32 module. I started a ST-Link utility and connected a programmer. Once firmware has been programmed, you could see that a second LED starts flashing rather quickly. Now with the board programmed, all I needed to do is to solder connectors. And now, by the magic of video editing, voila, we have the whole board ready. Today I will continue my work on the open inverter board. So hopefully I will connect the board and I will enable the PWM signal. So this signal will drive IGBT transistors on the inverter and eventually will drive the motor. First I tested the power with the current limited to 200 milliamps to ensure that nothing is short-circuited in the board and not drawing too much current. And we can see now that LED is on and flashing. Okay, now the exciting bit. I'm going to measure the PWM on the inverter there. Okay, let's have a look. Okay, just pick up the ground from here. Excellent. And now we started the inverter. That is quite strange. I'm not getting PWM signals. Crikey. Right, I'm getting some strange interference. Let's just check the power line. Ooh, same thing on the 3 volts. What's going on? It looks like maybe I have some sort of a fault on the board. Can't believe this. Right, I'm back again. I've just spent half an hour just trying to troubleshoot this issue. Actually, it's turned out to be the damn probe again. So let's see what I can measure now with a decent telescope probe that I had. And here we go, I'm just measuring. This is our PWM signal. I just need to synchronize it. Here we go, beautiful. Just stay there. Right, let me see if I can stop the inverter. Yep, I stopped the inverter and you can see that PWM signal is gone now. Again, start the inverter in manual mode and we have our signal back. Excellent. As I have PWM signal working now, I can repair the high voltage cable that I purchased with the inverter and prepare the motor to spin. Now all I need to do is to connect the cable on the inverter side as well as connecting the cables on the side of the gearbox. I connected a light bulb as a current limiting device. In parallel I connected the fuse and the switch. First I will pass the current through the bulb, so it will pre-charge the inverter. Once pre-charge is complete, I will use the switch to bypass the bulb and switch to direct connection. First I'm switching the power supply, so it's 12 volts. Okay, I powered on both power supplies, but for whatever strange reason the lamp is not lighting up, which is a bit of a puzzlement for me. And now I'm gonna try to bypass the bulb. No difference. Yeah, there's something is wrong. So, well, it's a good opportunity to learn and investigate. Hello. Well, as you can see, it's working. Why didn't it work last time? Stick with me to find out. Last time when I left you, I couldn't spin the motor. And I kept scratching my head, why? What did I do wrong? But first I started removing the inverter cover, and I found I forgot to attach the bolts that actually connect IGBTs to the output that goes to the motor. When I assembled the inverter first time, I put this frame in, so I put all these screws in place and all of these, but I forgot to put these screws. First I'm switching a low voltage power supply, and now I'm switching the two power supplies that provides so-called high voltage, and with a bit of a delay I'm now doing effectively pre-charge. By switching the switch I will bypass the bulb. Now I'm starting open inverter console. I will set up norm to 100 and F slips to 10. And we are. I managed to spin the motor in a sine mode. Next step would be to drive the motor in field oriented control. We will need to add two more components to our setup, resolver and a throttle pedal. Well, I suspect that's where the resolver is connected. So I have these two strands of wires, but one of the dilemmas that I'm facing is actually a resolver supposed to have 6 wires, and this one has 2 extra wires. So I've decided to try testing resistance of these wires, and let's start from those two. Right, that's 13 ohms. 13 ohms might be an exciter for the resolver. And that's 21.6 ohms. If this one is similar, then it's definitely a resolver. Bingo. So that's also 20.2, 13 ohms. So that's clearly an exciter. Well, last two clearly have much higher resistance. It's 56 kilo ohms. So I wonder whether this could be a temperature sensor.
The MG1 resolver and the MG1 temperature sensor.
I was a bit apprehensive before starting FOC tuning, as it proved to be tricky for many. However, it absolutely does require field-oriented control. First, I need to start connecting resolver wires. So I'll split them in 3 pairs. So effectively this is our exciter, and those two would be our sine and cosine. I went on the internet and I found the drawing of the connector for the resolver for MG1. I connected the resolver as per diagram, and now it was a time to test if it gives us the right reading. Right, so now I'm going to rotate the motor and we're going to see what's happening with the signal. Okay, so we are getting good reading now, and you can see that the encoder is reading from 0 to 360 degrees. After this I performed a field-oriented control tuning. This is a quite involved procedure where you change a manual ID current and look at the reaction of the motor. I'll spare you all the time of the process as it was quite long-winded, but basically as a result of this process we need to find sync-offs value, which will allow us perfect alignment of the electromagnetic current field against the permanent magnets that are in the motor. Okay, I've just connected the start inverter button. It's a momentary switch, we just press it in, it applies the voltage. And here is our throttle pedal. It's a Toyota Prius, or maybe the same as Toyota Prius pedal. It has wiper 1 and wiper 2, 55 volts power and ground. So this cable is connected to the arm seal connector. So I'm gonna try to use now throttle control. Here we go. The power supply on. So that's powering an inverter, and now the high voltage supply going through the bulb just to pre-charge. Now I'm just gonna press the start button. You can hear a bit of a whine. That means that inverter has started. And now but anyway, yay! We actually succeeded. So let's have a look at the graph. I plot the graph of the resolver. So we are getting variable speed. Yeah, it seems to be working. With MG1 job out of the way, I swiftly reconnected the cable over to MG2. It was actually much easier because the cable itself was made for MG2 in the first place, and I've just used it for MG1 while I was doing the testing. And now I could fit a proper Toyota cover, which will provide an extra shielding for the high voltage cables for the motor. And the last but not least, I moved the resolver wires to the resolver for MG2. So now they were all labeled, and of course that was much easier to do than the first time. Just in case, I did check the resistance of the wires to ensure that I appropriately connect exciter and resolver. Yeah, you can see now that's ring gear working, so if I hold it, I can actually stop it. So it only rotates this. So I'm not able to stop MG1 on its own. I performed tuning pretty much in the same order as I did with MG1, only I found the sync-offs value was much higher for MG2 in comparison to MG1. Now I'm gonna try and verify, see if it works with the throttle control. It's working with the pedal, baby. Look at that beauty. It's going. MG1 and the wheels. Now I'm gonna look at these contactors. It's a kilowatt 100 LEV contactor, so they control by 12 volts DC. In the open inverter board, we have number of FETs that operate various relays and contactors. So one of them can operate pre-charge relay and another one can operate main contactor. We're going to operate this sort of diagram similar to this one, except I will not be using the negative contact. At the start of the pre-charge cycle, the positive contactor will be open and pre-charge contactor will be closed. We will then charge the capacitor in the inverter through this pre-charge contactor and resistor. So once we completed the pre-charge cycle, we will then open pre-charge contactor and close positive contact. So at this stage the current will not be excessive and we do not need a current limiting resistor. So now we can connect our contact. This one will play a main contactor and this will be our pre-charge. The pre-charge will go into here where the yellow wire is. Okay, so that is connected. Yeah, so these two basically connected to the source of 12 volts, and this one is our pre-charge and this one is our main contactor. In theory, when I turn the power on, which is ignition, the pre-charge should turn on. Of course we will hear it, but let's just have digital voltmeter so we can measure it as well. Ready? 1, 2, 3, go! Yay! Pre-charge is on. No, it isn't. Ah, yes it is, because my TM is in voltage mode. Yay, it's on. And the main contactor should be off. Brilliant. This is exactly what we need. Now, if I press the start button, you probably heard the noise. The pre-charge should be off, and it is off. And main contactor should be on. Fantastic. That is working. This is the little project box I made. We have on switch, on-off switch, a start button here, and we have a pre-charge, main contactor, and it's all connected through this distribution block here. I've just switched on power supply, so we have 12 volts on the input, and this is the voltage after the switch, so we still have 0. Now if I turn the switch on, so we have 12 volts here. So I've just put the cover on and I connected the inverter. The power supply is on now. and inverter is on, and one of the contactors is engaged. It's a pre-charge. Now I press start and pre-charge is disengaged and the main contactor is engaged. Right, I'm now finishing the connection of the my project box. I've now connected contactors. This is the main contactor here, and connection goes to the power supply. And this is the pre-charge contactor. That we have a resistor here connecting the inverter, plus and minus. Right, so the power supply is on now. I apply the voltage, switching high voltage power supply. That is on, and we can now apply the power to the inverter and to the box. The contactor is on, so this goes through pre-charge at the moment. And now I press start, and this should hopefully start it in inverter. And now I should be able to try applying my throttle. So I'll put it somewhere here so you could see it. Okay, so that means parking pole is engaged. Right, so I need to try and disengage it now. Okay, I think we need to go this way. Yeah, I think that's disengaged. Okay, now I pulled back a little bit, so I brought back the throttle pedal. Wow, look at that. It's wonderful.